And the oxidation number for oxygen is -2, except when bonded with peroxides. So that's one of our rules for finding oxidation numbers. So, and the method that we're going to use is this formula that I think it works best for me and it makes the most sense to me. So I'll show you how that works, but let's start with the first answer right here. So ClO4 minus. In my formula, I multiply the subscript or the coefficient of the atom by the oxidation number of that element plus the oxidation number of the second element times the subscript or coefficient of that element, and I put it equal to the overall charge. So that's what works best for me, and you can continue it. You can keep adding. Say if there's 3 atoms in that compound, you can add you can continue this for a third atom. So it's pretty easy, and you'll see how it works in just a second. So ClO4 has a -1 overall charge, and so for our first oxidation number of that element, we don't know that yet, but we do know that the oxidation number of oxygen is -2. So for chlorine, we're going to put a dash here, and that's going to be times 1 because there's only one of it, and then plus the oxidation number of oxygen for one oxygen is -2 times 4, because as you can see there's 4 atoms, and an oxidation number accounts for only one atom of that particular element, so you have to account for if there's more than one. So we're going to multiply that by 4 and set it equal to the overall charge, which is -1. And that simplifies to something -8 is equal to -1. And to complete this blank, you can see that it's 7. So the oxidation number of oxygen in here would be -2, and the oxidation number of chlorine is +7, neither of which is equal to +5, so we can cross A off of our list. But let's move on to B. So MnO4 minus. And we're going to use the same formula that we just used here, except of course with different numbers. So we don't know the oxidation number of Mn yet. We're trying to figure that out, but we do know the oxidation number of oxygen because of our rules. So we'll do blank plus -2 because that's the oxidation number of one oxygen times 4 because there's 4 oxygens in this compound is equal to -1 because that's the overall charge of this compound. And then if we simplify that, it's -8 equals -1, and 7 fills in that blank just like it did here. So the oxidation number of oxygen here is -2, and the oxidation number of Mn is +7. Again, neither of which is equal to +5. So B is also off of our list. So let's move on to, this is nitrate, so let's move on to that. NO3 minus. And we're going to use the formula here again. Oxidation number of nitrogen, we're trying to figure that out. So we're going to leave that blank. And it's times 1 because there's 1 nitrogen. Plus, and because of our rules, we know that the oxidation number of oxygen in here is -2. So -2, and the subscript here is 3, meaning that there's 3 oxygens in this compound. So we multiply it by 3 and set it equal to -1 because that's the overall charge up here. So if we simplify that, it turns out to be blank -6 is equal to -1. And 5 would fit in, +5 would fit in that blank perfectly. So the oxidation number of oxygen here is -2, and the oxidation number of nitrogen is +5, which of course is what we're looking for. But let's move on to D just to make sure, and it doesn't hurt to get a little bit extra practice. So SO3 2-. So C is going to be our answer here. So it all builds on top of one of another, like each topic builds on top of the next, and oxidation numbers are very crucial to know. I think this formula here outlines it really well. It, I think, makes it a lot more clear than just trying to write the little oxidation numbers over each element. But if you want to write that out, I think it'll help save us from some simple mistakes. Okay, so for our second question, it's another question on oxidation numbers, but it's a little bit more complicated. It asks, which of the following compounds include an element that has the same oxidation number as the chlorine in NaClO3? So, a few important notes are compounds that don't contain hydrogen or oxygen. The most electronegative element has an oxidation number equal to its charge as an ion. And remember, electronegativity increases as you go right and as you go up on the periodic table. Oxidation number of hydrogen is +1 when bonded to a nonmetal. And it's really, really important to note that it's asking element, not compound, because some of these are polyatomic ions like cyanide or nitrate or ammonium. So those have their own charge, but then within those, we have to take into account each element, not just the compound as a whole. So if we want to find the oxidation number of sodium, and that's going to be ×1, because I'm using the formula that I used in my last problem, which is oxidation number times the coefficient or the subscript plus the oxidation number of the second element times the subscript or coefficient plus the oxidation number of the third element times its coefficient or subscript, and then you set it equal to the overall charge. And we know that the oxidation number of sodium as an ion is +1, so we can plug that in here, and +5 fits in there. So oxidation number for chlorine, what we're trying to find is +5. So let's keep that in mind as we find the oxidation numbers for the rest of the compound. Okay, so for this one, we have to focus on cyanide first because we'll start from the little stuff and work up. So for cyanide, it has an overall charge of -1. Nitrogen is the more electronegative element on the periodic table, and its charge as an ion is -3, so that's what we're going to fill in here. And so that simplifies to oxidation number of carbon -3 is equal to -1, and +2 fits in here, so we can put oxidation number carbon is +2, and the oxidation number of nitrogen is -3, but neither of those is equal to +5, so let's keep looking and keep working on this compound. So if we're doing this compound as a whole, we'll do the oxidation number of potassium ×3, because it's the subscript here, plus the oxidation number of iron ×1, because it has no subscript, so it's just 1. And cyanide has an overall charge of -1, so that is what its oxidation number is going to be, ×6, because that's the subscript that it has, and that will be equal to 0 because there's no charge on this, or the overall charge on this compound is 0. The oxidation number of potassium is +1, so we can fill that in. So oxidation number of potassium is +1. The oxidation number of iron is +3. And the oxidation number of cyanide is -1, and neither or none of these is equal to +5, so we can take A off the list. Okay, so since we know that A can't be the answer, let's move on to B. And B doesn't have any polyatomic ions, so it should take a little bit less time. Okay, so if we're using the formula, we're going to have the oxidation number of potassium is +1 times the coefficient, which is 1, plus the oxidation number of Mn, which we don't know yet, and we're trying to find that out, plus the oxidation number of oxygen, which is -2, times 4, which is its coefficient. And because the compound has no overall charge, the overall charge is 0, we're going to set that equal to 0. So none of those is equal to +5, which is what we're looking for. So we can check this one off the list also. Moving on to C now, aluminum nitrate. Aluminum nitrate includes a polyatomic ion like part A, so I'm going to start by finding the oxidation numbers of each element within nitrate, which has an overall charge of -1, and then we'll move on from there if neither of those is equal to +5, because +5 is what we're looking for. So nitrate. If we're using our formula here, nitrogen is going to be blank times 1 plus -2 times 3 is equal to -1, because that's the overall charge, and there's 3 oxygens in this compound. And then you simplify it so that it's blank minus 6 is equal to -1, and +5 would be perfect for nitrogen here, or that's what nitrogen has to be. But let's finish out the compound because it can't hurt and it gives us a little bit more practice. So if we're using the formula, aluminum is what we're trying to find, and that's ×1 because that's the subscript here, plus the overall charge of nitrate is -1, and the subscript is 3. So we'll multiply it by 3. And this compound has no overall charge, so we're going to set that equal to 0. So it's blank minus 3 is equal to 0. The oxidation number for aluminum must be +3. So we found here that the oxidation number for nitrogen is +5, so C is going to be our answer because that's what we're trying to find here. Okay, so our last multiple choice